Hello everybody, you're very welcome to this episode of Object-Oriented Programming. In this episode we're going to look at how Python implements objects. So we'll recall that an object really has two parts. It's what it does, which are its methods, and how you describe it, which are its attributes. And normally in object-oriented programming languages, how we create an object is we declare a plan or blueprint of the object called a class, and then when we instantiate or create an instance of that class, it's an object. So first we'll look at how do we declare a class. So in Python it's very simple. A class is simply declared as class name, then do whatever you want. And then, as you know, because I'm a fussy pot, I like to put in a comment at the end saying to end the class when it's over. So in this example I've put in the word pass. In Python what that means is don't do anything, pass on, move along, nothing to see here. That's all pass means. It just means, it's the same as null. It just means don't do anything. So just to look at our standard format of a class, our standard format is, as you can see, class name, do some stuff, and then end the class. Super duper. So if we were to run this class, my first class, and then be at the command prompt of Python, and we were to type in that A gets the value of my first class, then what we'd be saying is A is an instance or an object of class type my first class. So our object is A, our class is my first class. If then I said print A, it'd just tell me that space has been reserved in memory for an object of class type my first class, and indeed you can see the memory location is 0 in hex, 0x, it's 02D6, 0B10. So that's the location in memory that space has been allocated for this class that just says pass anyway. If I were to say then that B is assigned A, so that is to say whatever is in A gets into B now, and then I would say print B, we'd see that B has the same location in memory, 0x02 D60B10, because it's the same. A is a pointer to that space in memory, and then all we've said, when we say B gets the value of A, what we've said is add a new pointer into the same location in memory. But if we did say B gets my first class as well, so instead of saying B is just a copy of A, if we said let's create an object from my first class and call it B, then we'd find if we printed B that it would be the same kind of thing but at a different location in memory. So B now is reserved at 02D60B30. So it's exactly like variables that we've done in the past. A variable, you declare it. If you assign a new variable name the same value to the first variable, it has the same value. If you create a new variable with a new instance, it's got a different value. So classes work very much like variables. If we want to declare instances within a program, what we can just do is say class point, and this class, which it's our second class, it's called point. It doesn't do anything at the moment, just says pass. If I want to declare an instance of point though, all I say is, as we did before, instead of A and B, I just say P1 gets point and then P2 gets point. So that means we've created a new type called point, and we've created two variables of that value, P1 and P2. That's all that means. It's very straightforward stuff. And just to reuse our object-oriented terminology, the declaration at the top is creating the class, and then the declaration afterwards are creating objects of that class. So P1 and P2 are said to be objects of the point class. So that's nice and simple, and that's a nice way of distinguishing. So the class is the type, and the variables are called objects when we're thinking about object-oriented programming. If we want to add attributes now, what we do is we might say, let's say for example, point 1 has x and y coordinates. So point 1.x gets the value 5, and point 1.y gets the value 4. Whereas for point 2, its x coordinate is 3 and its y coordinate is 6. So just to be clear how brilliant Python is, if I want to add attributes to an object, So if I want to add x and y to point 1 and point 2, all I just say is the variable point 1, or the object point 1, gets dot x gets the value 5. So there's no declaration of attributes. You just add them in and stick values into them. And then if we want to print out the values, we just do print the normal way, point 1.x, point 1.y, point 2.x, point 2.y. So this is phenomenally simple compared to most other object-oriented programming languages like C++ or C# or Java, where you have to do all kinds of convoluted things to add attributes on. For this particular approach in Python, all we do is just say this object P1 has attributes x and y, and we put values in. So it's a really simple, really clear way of adding attributes. And in general, in Python, what we say is when we're adding an attribute, all we do is we just say the object name, we declare a new attribute or variable of that type, and we give it a value. So the same if we replace the word object with P1 dot x assigned 5. So just by putting in a dot and a variable under it, we've added a variable into the object. And we call that dot notation, not to be confused with the calculus. All right, so that's adding attributes. You just stick them in. Now let's look at adding methods. So adding methods is slightly more interesting because it's adding behavior, whereas adding attributes are just values you're adding in. When you're adding methods, you're adding behaviors to a class. So let's have a look at that. The first and handiest way we can do this is, let's say we have our class point and it has two values, x and y. And we saw before we assigned x and y to 5 and 3 or something like that. Let's say we wanted to have a method built into the class that if we say reset this object, it sets x and y to 0. This is how we put that in the class. So we declare a method the same way we've declared methods before using the def command. So we define a method called reset. And the reset command takes in whatever object we're thinking about at the moment. So the self means the current object. And all reset does is it says whatever value x has in self, set it to 0, and whatever value y has in self, set it to 0. So we'll see that in action. And again, just to be tidy, I've added in end reset method and end the class. So just to think about this again, we've got an object like a ball. Inside it, we've got methods and attributes. In terms of the attributes of the object, which is the point object in this case, the attributes it has is x and y. It's two values, like the xy coordinates in coordinate geometry. And then we've added in a method, which means if I'm thinking of P1, we'll say, so, or P2, any object of type point. If I say P1.reset, what that means is the values in P1 will be overwritten x and y, and they'll be set to 0. So adding methods is quite straightforward as well in Python. It's really neat. All you do is stick the methods inside the class declaration, and then they're available to every instance of that class. So let's see what that looks like. If I say P is a new point, so we've created a class of type point, and I'm creating an instance of that class, which is P. P is the object, therefore. Each point has two attributes, x and y, so p.x gets 5, and p.y gets 4. So if we print out p.x and p.y, we'll see 5 and 4. Now, all I need to do to reset those values to 0 is say p.reset. Because if we go back one slide, reset, as we can see, is a command that's embedded within the class. And what reset does is it sets x to 0 and y to 0. So the self in this case is P, the instance of point we're looking at. So if I run this program, when in the first print will print out 5 and 4, which is x is 5 and y is 4. Whereas after I run reset, it'll print out 0 and 0 because the values have been reset to 0 and 0. Because if we go back to the previous slide again, we see that self, which in this case is p, the instance of point, p.x is going to get the value 0, and p.y is going to get the value 0. So going forward then, we can see why it changes from 5 and 4 to 0 and 0 once we do the reset. So reset sets whatever coordinates, I think, to the 0, 0 line. I think in coordinate geometry that's called the origin point. So that's adding a method. You just put it in the class declaration. It's quite straightforward. We can also try an alternative approach. So if we look at that code again, instead of saying p.reset, which is cool and compact, we could also alternatively say the following. We could say point.reset for the variable p. So the class is point, the method inside it is reset, and if we just say for the variable p, for the instance of point that is p, or for the object p, it'll also do the exact same thing. So that'll also give us, it'll print out 5 and 4 and then 0 and 0, because we've reset p's x and y value to 0 and 0. This is neat. So with object-oriented languages, you can do the same thing in a few different ways. P is the variable or object of class point. If we say p.reset, it means set the values to 0. Equally as well, if we just say the general class point, call the reset function for the specific object p, does the exact same thing, means the same thing. It just means change x and y to 0 and 0 for the object p. Now let's look at a method where we take in multiple arguments, more than one, so more than one value being passed in. We'll remember our method we have already, which is reset. So what does reset do? It just sets x and y to 0 and 0. Now let's do the same thing, but in a slightly different way. Let's create let's jump down and have a look at the reset method there. The reset method now says, instead of setting x and y to 0 and 0, what it says is move the numbers 0 and 0 into whatever object we're talking about. So what does move do? Well, if we go up to the top method, move takes in two values, a and b, and whatever values it's getting in for a particular object, which is the self object again, it writes the x value stored within the object self, puts the value a into it, and for the attribute y, it writes the value b in it. So this is a general method that I can put any two values. It's not just 0 and 0. I can put any two values in x and y now. So let's say I declared a variable of point. Let's say I call it p1. And I said p1.x is equal to 1 and p1.y is equal to 1. And then if I said p1.move, open bracket, 5, 5, then x would become 5 and y would become 5, because all the move does is it replaces x and y with whatever values you pass into the move method. And then we can think, if we think about the reset function is just one instance of move. Reset is a very specific one where you're not putting in any values a and b, you're putting in the specific values 0 and 0. So if I move the values 0 and 0 into the current object, it means x gets 0 and y gets 0, passed through the variables a and b. So if you're having trouble with that, run the code and see how it works. But that's multiple parameters, multiple arguments into the move. It's taking in the current object, which is self, and a and b. All right, and just to say it again, we've declared a new object, a new method called move that writes values into the object, and then reset simply becomes a move of 0 and 0 into the current object. So if we want to calculate the distance between 2 points in a Cartesian plane, oh my God, this sounds like fun. How would we do that? Well, we will remember way back when we had much more hair and had much less stress. There's something called the theorem of Pythagoras, and we know that the square of the hypotenuse is equal to the sum of the square of the other two sides. So if I have 2 points in a plane, and one point is 6, 5, that's what B is, and A is 2, 2. the distance, the horizontal distance between A and B is 4 and the vertical distance is 3. Therefore, the length of D, the hypotenuse, is x2 minus x1. So it's x2 is 6 minus 2 is 4. And y2 minus y1, 5 minus 2 is 3. So if we square 4 and add the square of 3 to it, we know what we get. We get 16 plus 9, which is 5. And we get the square root of that, then we find out that D is 25. If you can't remember this, have a look at your maths books. So all we're doing is getting the distance between 2 points by subtracting the coordinates from each other. So 6, 5 minus 2, 2 is 4, 3. Square them, add them, square root them. You've got your distance between 2 points. You can see it in the picture there. D is obviously 5 because one side is 4 and one side is 3. Perfect. So if you can remember that, if that makes sense, we know what we have already. We can do move and reset, so they're good. So let's add another method in. And that method is called calculate distance. And how calculate distance is it takes in a point and another point, and then it returns the square root, so that's math.square root. So because we're using a maths function, the square root function isn't built into Python, but we have it in a library called the maths library. So at the very top of this code, just beside the title, you can see I say import math. We remember we talked about this before, importing particular programs from a library. So calculate distance simply gets the square root of the first object's x value minus the second object's x value squared plus the first object's y value minus the second object's y value squared. So all we're doing is getting d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's all we're getting, and that's how we calculate distances. So then if we add that together with the other program, suddenly we can start calculating distances. So what would our code look like? If we declared 2 points, P1 is of type point and P2 is of type point, and let's say we put the value 2, 2 into point 1, and then we put the value 6, 5 into point 2. We could just say P1.x equals 2, P1.y equals 2, P2.x equals 6, and P2.y equals 5, instead of doing P1.move 2, 2, P2.move 6, 5. But God, this is so much quicker than, again, let me say it again. For P1.move 2, 2, we could say P1.x 2, P1.y 2. For P2 move 6, 5, we could say P2.x 6, P2.y 5. But that's so slow and so 5 minutes ago. So then if we want to print out those values, the first print line prints out 2, 2, the second print line prints out 6, 5, and then the third print line will print out the distance between P1 and P2. How do we calculate it? We say P1, we could pick either object, but we'll pick P1 and say P1.calc distance. Calculate the distance from P1 to, open brackets, P2. So we'll remember when we declared the calc distance program, we had two objects going in. One is called self, and the other is called other point. So the self is P1 in this case, because it's P1 dot, and we do calculate the distance. So we know what this will work out to be. It'll work out to be 5, or probably 5.0, because it'll probably convert it into a real number when you're getting square roots, just to be sure, but it's going to work out to be 5. What you're going to get here is P1-x, comma P1, P1-y is 2, 2, P2-x, P2-y is 6, 5, and then distance from P1 to P2 is 5, because that's how we're going to do the calculation. And if you run that program, you see that working. So that's it. Have a go with the code. Well, thanks very much. We'll see you on the next episode.